I'm back. So hello again. So in the previous lesson, I have discussed there how to expand the binomial. And for this lecture, it will be a continuation of that lesson. But this time, our goal is in finding a specific term in the expansion. So let's say we would like to consider the rth term in the expansion. So let's say in an example, let's go back to an example. So let's say in the last example that we had, so if this is now our final, if this is now our final expansion, let's say we would like to find just this term of the expansion. For this example, it must be the first, second, the third, the fourth, the fifth. This is now the fifth term of the expansion. So the question there is, if we want now to find this term only in the expansion, how do we do it? Of course, one possible solution that you can do is still complete your expansion and then just pinpoint which one is being required. But of course, the process of that will be very tedious kasi if our n is very large, then you will be needing a very, very long process in finding the entire expansion, and you just need one term. So for today, we would like to devise a way in finding just the single term of the expansion. And specifically, we would like to take the rth term of the expansion. So still, for this consideration, let's say we are still having the binomial a plus b, and then we are still raising this to our nth term. So if you will just review very quickly, let's go back here. So if this is now the fifth term, if you will observe, so still in that expansion or in the element in that expansion will definitely involve again the product. So that's the fifth. 1, 2, 3, 4, 5. So we're looking at this actually. So that element will have again the product of the two terms in the binomial. Okay. And we will have the specific exponents. And then we will have the specific numerical coefficient, and then we will also have the specific sign depending on the sign given here. So kung positive ito, so there's no problem because every term in the expansion will be positive. But if it's negative, then there must be a pattern. So how do we now do it? So let's observe again. So if you will look at this one, if this is your consideration, actually, we can have the formula again for the numerical coefficient. So that's very important. So if we will look at this example, for the first term, we have, if n is equal to 6, for the first term, we have 6 combination 0. If we have the second term, we have 6 combination 1. If we have the third term, 6 combination 3. If you will be observant, that remember we're using the formula n combination k. So if you will observe k here, okay, if we are looking at the rth term, or if we are looking at the first term, k is 0. If we are looking at the second term, k is 1. If we are looking at the third term, k is 3, and so on. Therefore, if we are looking at the rth term, if we are looking at the rth term, this has the implication that the k that we will be using is So if we are looking at the rth term, look at it will be k will be go back here. If we are looking at the first term, k is first term, k is 0. If we are looking at the second term, so your r here is 2, your k here is 1. Okay, so it means your k must be equivalent. Your k, let me just fix this one. So if we are looking at the rth term, this means that k is equal to r minus 1. Is that correct? Look at again the pattern. If we're looking at the first term, k is 1 minus 1, k is 0. If we're looking at the second term, your k is 2 minus 1. Okay? Thus, if we will now consider again the rth term, then the rth term, our rth term will involve a times b because we have a and b. And then for its coefficient, we're looking at the rth term. It will be n combination k, where k is r minus 1. Where k, diba? Where k is r minus 1. How about the exponent? How about the exponent? Let's go back to the example earlier. So if we are looking at the fifth term, this is, halimbawa mas madaling tingnan. So we're looking at the fifth term. This is 2 and 4. If we're looking at the sixth term, we have 1 and 5. If we're looking at the second term, we have 5 and 1. So what can we observe? I think we can observe here the exponent of the second element. Okay, so if it's the fifth term, our r is 5. This is 5 minus 1. If we're looking at the sixth term, it's 6 minus 1. If we're looking at the seventh term, it's 7 minus 1. If we're looking at the third term, it's 3 minus 1. If we're looking at the second term, it's 2 minus 1. Therefore, this means now that if we're looking at the rth term, we can determine the exponent of r, and this will now be r minus 1. So that must be r minus 1. And then, since the sum is always equal to n, so this must be n minus r minus 1. There you go. And then, if we will now examine the sign for this one, if again, the sign in between here is positive, definitely we know that this will always be positive. But if the sign here is negative, there will be instances that this will be negative. And when will that be negative? Look at this. This is negative. Where are the terms having a negative sign in the expansion? That's 1, that's 2, that's 3. Paano yung positioning nila? This is the second term, the fourth term, this is the sixth term. Therefore, what can we say? If this is negative, then this will be negative if the position of the term that we're looking at is even. So it means we can say here that this will be negative when R is even. Okay? But that will only happen again if this is also negative. Okay? So did you get that? So those are the necessary things that we need. Of course, here we can already change our k by n minus r. Therefore, if we will now finalize our formula for this one, so for the rth term, it will now be n combination k, where k is r minus 1. That's the numerical coefficient. And then this is a raised to n minus the quantity r minus 1. And then b raised to r minus 1. So we need the value of r. Let's look at an example. And first example for this one is, let's say we would like to consider the fourth term. Okay, let's find the fourth term in the expansion of r. Let me use another letter. Let's have a minus 3b raised to 6. Okay, so what are the necessary things that we will have here? We're looking at the rth term. So r is 4. And our n is equal to 6. So we're looking at the fourth term of the expansion of a minus 3b raised to 6. So if we will now have the fourth term, then we will have a multiplied by 3b, and then we have our numerical coefficient. For our numerical coefficient, our formula, this will be n, and then we have k, or this is r minus 1. But our n is 6, our r is 4, 4 minus 1 will be 3, okay? And then for the exponent, what did we say? This will have an exponent r minus 1, and this will have the exponent r minus 1. Let me just fix that again. So that's n minus r minus 1. Okay, therefore, what do we now get there? This will now be a raised to, our n is 6, minus r minus 1. 4 minus 1 will be 3. And then we have 3b raised to r minus 1. R is 4 minus 1 will be 3. And then take note, this is negative. We are looking at the fourth term, therefore r is even, thus this must be negative. This must be negative. Therefore, our final answer will now be, so let's just have the computation. We have 6 combination 3, 6 combination 3 will be, by formula, it will be n factorial over k factorial, or that's 3 factorial, times n minus k factorial, that's 6 minus 3. So that's 3 factorial. Or this is the same as 6 times 5 times 4 times 3 times 2 times 1, or that's 3 factorial, divided by 3 times 2 times 1 times 3 factorial. 3 factorial, 3 factorial will cancel out. 3 times 2 is 6. 6 and 6 will cancel out. Therefore, this will be 20. Thus, num our numerical coefficient will be 20. So that's negative 20. A raised to 3 multiplied by 3 cubed multiplied by b cubed. Or furthermore, this will now be 27. 27. 3 cubed is 27. 27 times 20. Pag 27 times 2, that's 54. Then a fixed 0, that will be 540. So our final answer will be negative 540 a cubed b cubed. So that will now be the uh, fourth term in the expansion of a minus 3b raised to 6. Let's have another example. Another example is, let's say we would like to look at the ninth term. Okay, the ninth term in the expansion of the binomial 2x, let's say, plus y raised to 11. This was what I was saying earlier. If you would like to find the ninth term and you would like to expand this entire thing here and just get the ninth term from that expansion, then the process will be very tedious. Okay? While if you will have your solution, then you just identify the following. Your n is 11. Remember, you're looking at your rth term, 9, your r is 3, right? Your r is 3. Therefore, if your r is 3, you need your k, right? So your k is r minus 1. Therefore, you will now have this as n is 11. Your k is to be identified as r minus 1, or your k is equal to 8. Your k is equal to 8. And if you will now consider the ninth term in your expansion, you will have, of course, the product 2x times y, and then you also will have the coefficient. So your coefficient, your n is 11, so that will be n combination of k, or that's r minus 1, that will be 8. And then what's the exponent here? Your exponent here is r minus 1. Your exponent here is n minus r minus 1. So this will now be 11 combination 8. And then you have 2x raised to, your n is 11, r minus 1 is 8. So 11 minus 8 will be 3. And then your y will be r minus 1 is 8. So again, you can check. Ninth term, the second element must have the exponent of r minus 1. That's 8. The sum must be n. That is 11. So we have done it correctly. So we just need the computation. Let's place it here. 11 combination 8 will be n factorial. That's 11 factorial divided by n, that's k factorial. That's 8 factorial times n minus k factorial. 11 minus 8, that's 3 factorial. 11 is 11. times 10 times 9 times 8 times 7 times 6 until times 1. But you find here 8 factorial. So we just place there 8 factorial divided by 8 factorial times 3 factorial, 3 times 2 times 1. 8 factorial will cancel out. 9 divided by 3 is 3. 10 divided by 2 is 5. This is 15 times 11. 15 times 10 is 150 plus 15 will be 165. So 165. Therefore, this will be 165. By the way, what will be the sign? Good thing, this is positive. Therefore, this is also positive. Positive. So that's positive 165. And then that's 2 cubed x cubed. And then y to the 8th. Or what's 2 cubed? 2 cubed is 2 times 2 is 4 times 2 is 8. 8. So that's 165. 165 times 8. So that will be 40, carry 4. That's 48. 52, carry 5. Then that's 8 plus 5 is 13. So this will be 1320 x cubed y to the 8. So that's an example. And a second example, so we have 1/3, or the final answer is 1320 x cubed y cubed. And let me just give additional problems maybe. So let's say you can work on this following exercises or following examples. Let's say find the seventh term in, let's say, x minus 3y raised to 9. And then a second example that you can work on. Let's say find the 10th term in a minus, let's say, 4b raised to, let's say, 12. Okay, so please work on this sample problems. Just follow what we have done in the previous examples. So this video clip will be shorter compared to the first one. Again, you can just go back to the lectures. Again, also, as I have mentioned in the first video, if you have questions, please feel free to message me anytime. Feel free to ask me anytime. As long as your message will come in, then I can answer your questions or your queries. Again, God bless you, everybody.